Hello and welcome to Earthquake Tip number 19. My name is Shailesh Agarwal, Executive Director of BMTPC, and I'm going to present to you all about earthquakes, its concepts, terminologies, and how to construct buildings and structures to withstand earthquake forces through 32 earthquake tips, which are authored by Professor C.V.R. Murthy, mentored by Professor Sudhir Kumar Jain, and developed by IIT Kanpur in association with Building Materials and Technology Promotion Council, that is BMTPC. Through these tips, our aim is to spread right technical information in simple to understand language to our professionals who are in the field designing and constructing structures and buildings, especially our architects and engineers. But before we start, let's make a pledge that any new structure or building we design or build must be earthquake resistant. The earthquake tip number 19 will explain you how columns in RC buildings resist earthquakes. In the preceding tip number 18, the behavior of beams under earthquake shaking, their failure mechanism, and reinforcement detailing was discussed. In this tip, we will discuss the column, which is a vertical member in reinforced cement concrete building. As you can see in this figure, the column contains two types of steel reinforcement, namely long straight bars called longitudinal bars placed vertically along the length and closed loops of smaller diameter steel bars called transverse ties placed horizontally at regular interval along the full length of column. As told you during beam details, these transverse ties or closed loop links play a very important role in earthquake resistance. Now let's look at the failure or damages column sustained during earthquake shaking. The first is axial flexure failure, also known as compression bending failure, which means buckling or crushing of columns. Next is shear failure, which is shown in this figure 2b. Shear failure is brittle and must be avoided in columns by providing transverse ties at closer spacing. Based on these failures likely to occur during the shaking, let's discuss the design strategy for columns. Designing of column involves selection of material to be used, that is grade of concrete and steel bars, size and shape of cross-section of columns, and amount and distribution of steel reinforcement. Selection of material and size, shape of column are part of overall design strategy of whole building. The IS 13920, that is the ductile detailing code, gives reinforcement detailing for the column. As per the code, the column should be at least 300 mm wide, and if supported length of column is less than 4 meter and beam length is less than 5 meter, the width of column can be up to 200 mm. Let me repeat again, columns that are required to resist earthquake forces must be designed to resist shear failure by a skillful selection of reinforcement, which will be seen here in this figure 2. As you can see here, a typical horizontal close tie for columns as per 13920. These ties, when closed space, help in three ways. Number one, carry horizontal shear force induced by earthquakes and thereby resist diagonal shear cracks. Second, holding together the vertical bars, that is longitudinal bars, and prevent them from excessive bending onwards, that is called buckling. And thirdly, containing the concrete in the column with the closed loops. Please note the end of ties must be bent at 135 degrees as shown in this figure. Such hooks and prevent opening of loops and consequently buckling of concrete and buckling of vertical bars. A typical shear failure due to lack of 135-degree hooks and large spacing of ties is shown in this figure 2b during Bhuj earthquake of 2001. Now let's look at the provisions of IS 13920 for earthquake resistant columns through this figure. As you can see in this figure, closely spaced ties must be provided at two ends of the column over a length not less than larger dimension of column or 1/6 of column height or 400 mm as shown in this figure. The vertical spacing of ties at two ends and below beam column junction should not exceed d by 4, where d is the smallest dimension of column. That is, in rectangular column, d is the length of small side. This spacing should also not be less than 75 mm or more than 100 mm. At other locations, ties are spaced as per calculations, but not more than d by 2, where d is the smallest dimension of column. The length of tie beyond 135-degree bends must be at least 10 times the diameter of steel bar as shown in this figure. This extension beyond the bend should not be less than 75 mm. Now let's look at this figure, which explains that in column where spacing between the corner bar exceeds 300 mm, diagonal links with 180-degree hook ends for ties to be effective in holding concrete in its place and to prevent the buckling of vertical bars need to be provided. These links need to go around the vertical bars and horizontal ties as shown in this figure. Special care is required to implement this properly at the site. Now let's look back at the earlier figure again to understand lapping of vertical bars. As you all know, in the construction of RCC buildings, due to limitation in available length of bars and due to constraints in construction, there are numerous occasions when column bars have to be joined. A simple way of achieving this is by overlapping the two longitudinal bars over at least a minimum specified length called lap length. This lap length depends on type of reinforcement and concrete. For ordinary situation, it should be about 50 times the bar diameter. As shown in this figure, IS 13920-1993 prescribes that lap length be provided only in the middle half of the column, not near the top and bottom ends. Also, only half the vertical bars in the column are to be lapped at a time in any story. Further, when laps are provided, ties must be provided along the length of lap at a closer spacing, not more than 150 mm. This is all about earthquake tip number 19. You can download the tip from www.bmtpc.org. The next earthquake tip, that is tip number 20, will be on how do beam column joints in RCC buildings resist earthquakes. Thank you.